In today's video, we're going to be taking a look at Welch's T-Test in Python. We're going to go through a few different examples, including a manual calculation, and then some shortcuts with SciPy. Now, this is an extension of the previous video that I made on the independent two-sample T-Test, and that one we took a look at the variance being the same, whereas Welch's is going to be different between the two different groups. So let me jump into some slides really quick, and then we're going to code through a Python notebook. Okay, so some background information on unequal variance for the independent two-sample T-Test. So a little background on the independent two-sample T-Test first. This is considered an unpaired test where we look at the means of two independent groups to determine if there's a significant difference between them. And this test assumes that the data comes from a normal distribution. Two groups are independent of each other. If you want to compare multiple, use ANOVA. We'll be covering that in another video. But regardless, test scores between two different classes, effects on choose of a marathon time. These are two pretty quick examples, although we're not going to be using these in this video. I have a bunch of other examples to take a look at. All right, this is where you're going to start when I care more, pooled versus Welch's T-Test. So if you have equal variances among these two different groups, you're going to go with the pooled approach. If they're not equal, you're going to use Welch's T-Test. Both these have different calculations for the T-statistic and the degrees of freedom. So equal variance uses the pooled variance in the denominator, degrees of freedom n1 plus n2 minus 2. Welch's use separate variances in the denominator and uses a formula, which is pretty complicated, but I'll show you that, and we're going to code out one example of the manual formula. All right, so the way to determine if there's equal or different variance, we're going to use Levene's test. I have a full video on Levene's test if you want to check that out. But regardless, the null hypothesis states that all group variances are equal. The alternative hypothesis states that at least one group has a different variance. And your typical significance level in this test is going to be 0.05. In fact, the whole video we're going to be using a significance level of that. But regardless, let's keep moving forward. So let's get back into our independent two-sample T-test with unequal variance. So our null hypothesis, right, and this is just for the T-test that we've been going over in this video, it means that the two different groups means are equal and there's no significant difference. It's the null, right? The alternative one states that there is a significant difference between the two means. And what do we consider a significant difference? Well, it depends if you go on the one or the two-tail. So if we go with the two-tail test, we're just looking at them being different. It could be lower, it could be higher. It doesn't really matter. If we're looking at one tail, right, we're only looking one direction, right? We're saying either the mean is lower or the mean is higher for one group. And that's the difference between one or two tails. So here's the steps on how to look at a two-sample T-test with unequal variance, right? Step 1, determine the null alternative hypothesis, confidence level, and the tail direction. Step 2, find each mean. Step 3 is Levene's test. Well, since we know Levene's test over here, we know we have to find the variance of each group now. And calculate the T-statistic, find the degrees of freedom, find the p-value, compare p-value to significance level, and then make a conclusion. Very similar to equal variance, except now we have to find each group's variance, and then we're going to do a little bit of a different formula for the degrees of freedom. Sorry, it's a little more complicated. All right, let's take a look at this example over here. On the one with equal variance, again, very similar. I changed up the numbers a little bit in this video, so that way they would have unequal variance. So here we go. We're looking at the 10K time between two running groups. The null hypothesis, there's no significant difference between the average 10K time of the two running groups. Alternative, there is a significant difference between the average 10K times of the two running groups or clubs, right? And this is a two-tailed test since we're looking at any difference between the two groups. We're not specifying anything like that. And then our confidence level is going to be 95%, right? Okay, so now what we're going to be taking a look at is step 2, finding our mean. So the mean 10K times in minutes, right? For club A is going to be 50 minutes. Club B is going to be 56 minutes. If you don't believe me, add those numbers up and divide, right? Then we're going to perform Levene's test. Now, I'm not going to show you how we did Levene's test here. It's quite easy in SciPy, but again, full video on Levene's test if you want to learn it. We get 0.06, right? So we reject the null hypothesis of equal variance, and we cannot assume equal variance, and we're going to have to use Welch's T-test. All right, now we go into calculating individual variances. Since we're samples, we're going to calculate it through the sample variance. A is 1.78, B is 15.78. Then we're going to calculate the T-statistics. That the formula here to the right. Plug in all of our numbers, right? 50 minus 56 divided by 1.78 divided by 10 plus 15.78 divided by 10. We take the root of that. I get a value of negative 4.55. Then we have to find the degrees of freedom. That is that fun formula over here to the right. And instead of putting every single step on how to calculate that formula, I mean, all we have to do is literally plug in numbers. I'm going to give you the DF value. That is going to be 3.087. Then we find our p-value, right, which is very, very low. Since we know the p-value is less than alpha, we reject the null hypothesis and conclude there is a significant difference in average 10K running times between Club A and Club B. All right, I know I covered a lot. It's probably been about 5 minutes going through these slides. So I want to jump you guys through some Python code now. It makes things way easier. And make sure to grab your notebook and let's start coding. All right, let's get started. So import numpy as np from SciPy import stats. Once both of those are in here, let's set a random seed. So np.random.seed 42. And let's set our alpha value for the video. So alpha equals 0.05. And let's take a look at example 1. So example 1. And we're going to look at the K per 9 on 2 different teams. Add strikeouts per 9 innings if you aren't a baseball fan. 2 teams. And we're just going to look and see if they're different or not, right? So first hypothesis is going to say the 2 teams, there's no difference. And then if we have a p-value low enough, it's going to say these 2 teams do have a difference in K per 9. All right, so let's take a look at that. I'm going to pass in my values. So I have team A over here that has a little bit of a higher variance. And then I have team B. Feel free to pause the video and just grab these values. I'll read them out. 10.2, 13.5, 9.9, 7.7, 10.1, 9.8, 10.4, 9, 7.6, and 12.3 for team A. Team B, 7.8, 7.9, 8.1, 7.5, 7.7, 7.6, 8.2, 7.4, 7.3, and 7.5. All right, so both of those are in here. Let's calculate the means for both these. So we'll say mean A equals np.mean, and we'll pass in team A, K through 9. And then I'm literally just going to copy the same line because we're going to do the same thing for B, right? We'll get the mean over there. And yeah, so run both of those. Let's print out our means. So print mean A, and then we'll print out mean B. So print, and we'll grab mean B. Right, so we have both of these here. Mean A, 10.4, then B, 7.7. And what we can do now is we want to compare, to see if the variance is different. So we're going to use a Levene. Now, a little bit of a shortcut since I'm going to use the SciPy Levene, but this video isn't mainly about Levene, right? We're taking a look at the independent 2-sample T-test and why we'd be using Welch. So I feel like we could use this shortcut here. So we'll say Levene stat and then Levene p-value equals, and then we'll do stats dot Levene, and we'll say our team A and team B. So pass in both of those and run that. And all we want to see is that p-value, right? We want to have a p-value under 0.05. I could do an if-else statement, but I'll save you guys some time, right? And p-value 0.02, awesome. So that means that we have a different variance between team A and team B. So let's move into that side of things where we take a look at Welch. So let's find the length of both, right? Now we already know the length of both. We could just literally sum them up. Or just add them up, not sum them up, but either way, they're going to be the same for both of them because I made sure they're the same. And I'm just doing NA and NB like this, right? And if you want to just see really quick, print NA out. Again, they're going to be the same for both, right? No need to. And they're going to be 10 each. Perfect. All right, now let's find the variance of both. So I'll say var A equals np.var, pass in our team A, and we'll just literally duplicate this line, do that for B. And what I'll do also is we'll leave a line just to print out the variance for both these. Again, show you that they are different. So print out variance of A, right, 2.92, and then print out our variance of B. We'll run both those cells. You can see 0.079. All right, decent difference. So Now what we're going to do is we're going to calculate our t-statistic. So we're going to say t-stat equals, and then over here we'll have mean of A minus mean of B. And then what we'll do next is divided by np dot square roots. And inside over here, first we'll have variance of A divided by NA. And then we're going to say plus, and inside over here, we'll have variance of B divided by NB, like that, for our t-statistic. Then let's print out our t-statistic, right, 4.24. And now let's get our degrees of freedom. Now, I'm not going to lie to you guys, there's a lot of code for our degrees of freedom, a lot of math. That's our manual calculation. Kind of yucky. So feel free to pause the video. Right, I'll just go through it. Right, 2 parentheses var A divided by NA plus var B divided by NB. All these are in parentheses. We square that. We divide that. We have 3 parentheses here. Right, var A divided by NA. Square that. Divided by NA minus 1 plus. Then over here, var B divided by NB squared divided by NB minus 1. Yeah, there's a ton, right? And I apologize for not typing all that out, but I know for a fact I'm going to make an error. It took a little bit to get. All right, so let's find our p-value now. So p-value equals stats.t.sf, and then np.absolute, t-stat, and then we'll say df. And now we can have a if else on this side of things. And this if else matters a little bit more. So reject the null hypothesis, right? There's a significant difference between the two teams, K9, pair 9. And the reason why we know that is our p-value is going to be very, very small. And we grab our p-value here, right? Look at that. Way less than 0.05, and that is why we reject the null hypothesis. The teams have different K per 9s. All right, that was a lot of work. Well, really, it was just the t-value and the degrees of freedom. But yeah, let's take a look at example 2. This is going to be much easier now, right? Because now we're going to utilize SciPy. So example 2, I'm going to pass in 2 clubs over here. This is our running club example. So let's say running club example from the slides, and I'll show you how easy this is now, right? So we have club A, and we'll also have club B, and like above, let's first do Levene's test, right? So we'll say test, Levene test statistic, and then p-value, and we're only looking at the p-value, right? Levene equals stats dot Levene, and then pass in both of our clubs. So we have club A, club B, and then I'll say center equals mean. Probably should have put that on the first one, but oh well, right? So we have all of that now, and let's print out our p-value. So print out p-value for Levene, and 0.06, again, less than 0.05. So we reject the null hypothesis and we go with the alternative hypothesis that they have different variances. And then now let's find our t-statistic. So t-statistic and our p-value equal, and we can say stats.t-test independent t-test, that, passing club A, passing club B. And then here's the key thing that you say equal variance, var equals false, right? They don't have equal variance, right? And I do have an error over here. It's no underscore t-test like that. And now I can print out our p-value and t-statistic, right? T-statistic over here, negative 4.52. Then we print out our p-value, right? It's going to be close to 0. 0.0008. And yeah, that matches up with what we went over in the slides. So let's take a look at one more example. So I'll say example 3, 400 meter. And we're going to take a look at a one-tail version. One tail. So we're going to have professional runners versus college runners. So let's grab that. So I'll say professional runners equals, and we're going to generate this data this time. So we'll say np.random.normal. We'll say 44, 0.5, and then 30. Nowhere near 44 seconds for a 400 meter for me. I'm pretty slow at short distance. So college runners equals np.random.normal. Then pass in 48, 2, and 30, right? Much larger standard deviation, but we'll still do the Levene test just to show you guys, right? And if you want to see the times, not that really matters, but we go over here, right? If you want to see some of these over here, boom, those are some of the times. Okay, now let's find our values. So we'll say c-tat Levene, then we'll say p-value Levene, p-value Levene equals stats.Levene, then pass in our professional runners, then pass in our college runners. We'll say equal var. Oh, we don't have the equal var. It's the next one. It's equal var. I almost messed it up, man. We will say center equals mean, right? We want to specify our center. All right, and let's print that out. Print out our p-value. And 1.45 to -7. So essentially 0. Again, we can reject the equal variance. These are going to have different variances. And you should have known that by how we generated this data, but regardless. All right, now what we can do is perform our test. So we'll say stat, and then p-value equals, and stats.T-Test independence, then pass in our college and professional runners. Both of those over here. College runners, pass in our professional runners, and then we'll say equal var equals false. Right, and then lastly, I'll just paste in my if else. Right. And we have our one-tailed test. Our t-statistic is 11.01. And then we have our p-value of 8.7. And I forgot to paste this in over here, but if t-stat greater than 0 and one-tailed p-value less than alpha, there's a significant difference, right? And there's a significant difference between the college athletes and professional runners. So let me look over here, right? 44 versus 48 seconds, a lot small standard deviation, and they both had a sample size 30. So yeah, that's essentially Welch's T-test. Just remember, use Welch's when you have different variants. You use pooled when you have the same variance. SciPy makes it super easy. All you have to do is change this equal variance here at the very end for T-test independent, right? Just make one true if you want to use pooled, false if you're going to use Welch's T-test. And yeah, hopefully you have independent 2-sample T-test down. And hopefully you don't have to manually calculate this, because that degrees of freedom calculation is kind of gnarly to type all of that out. I'm not going to lie. Thank you, SciPy, for making our lives much easier to get this p-value. Hope you guys found this video on Welch's T-test helpful. And if you did, make sure to subscribe to the channel. One of our goals here is to reach 100,000 subscribers in 2025. We're uploading at least 3 to 4 videos every single week because of that. Now, if you want to learn even more about statistics within data science, I have a few videos linked down below in the description and a playlist right over here that you can watch.